Okay, good evening all. My name is Harpra Minhas and I'm doing my PhD in Department of Chemistry IIT Indore. So this course has been assigned to me so I will be your TA for this particular course, that is Introduction to Chemical Thermodynamics and Kinetics, code as NOC23-cy38. So for the upcoming sessions, I will be your TA and I will be taking your weekly assignment practice sessions and a live interaction. So whatever problems you will be having, we are going to discuss in this 2-hour session. So on every Friday for the couple of weeks, maybe three or maybe upcoming 2 to 3 months, we are going to meet at the same timing from 6 p.m. to 8 p.m. So we are going to cover up our assignments based on your weekly task or the videos that you have watched, or any problems that you are facing, and these assignments and our interaction will help you to further solve your assignment that has been given to you. Okay, one more thing. If this session interrupts in between due to some internet issues or even after 1 hour, so I request you all to join this link again, so that we could continue for the next for continuously for the 2 hours. So shall we start?
Yes, ma'am, you can start.
Okay. Okay, in the very first week, what you people have studied is regarding, I think, your ideal gas and the real gas behaviors, their equations, and the critical temperature, Boyle's law, and all, right? So let's quickly recap all the equations that you have gone through in this week. So everyone knows this ideal gas equation, right? Okay. So for these, but for the real gas systems, this ideal gas behavior or this ideal gas doesn't follow. So in that cases, we have to include certain type of correction to this equation. That is based on your one is your interactions, and other is your the one parameter is your A and another parameter is your B. This is being used for to correct this ideal gas equation. So after correction, your equation becomes okay. Okay, for when your number of moles are 1, so then equation by putting in the here, your equation will look like this. Okay, so these are the basic things that you have already read. So other things that you have might be gone through is your critical temperature or Boyle's law, or these type of formulas like for PC, TC, and VC. right? So these are the some basic equations that we are going to use in our upcoming assignment questions. So let's move to the questions then. Okay, this is your first question. So the boil temperature is the temperature at which the real this gas behaves ideally, that is real gas behaves ideally at what condition? So anyone would like to answer this question?
When the pressure is low.
Okay,
Option D.
option D, that is when the pressure is intermediate. Anyone else? Anyone else? Sorry? Okay, so the correct answer is B, when the pressure is very low, and other side your temperature is very high. So this is the condition when your this real gas is starting behaving as an ideal gas. So that means your B part is correct. That means for a gas to behave like ideally, it should follow So these are the two conditions that a gas should follow to behave as an ideal gas. Okay, shall we move to the next question? Okay, let me add some few points to this question. So one is your Boyle's temperature. So anyone would like to tell me what is this Boyle's temperature?
The temperature above which gas cannot be liquefied. No, it's a critical temperature.
Yeah. Okay. But it's a good try. Okay. So this is a temperature at which your gas behaves an ideal gas and obeys the gas laws. Okay. So that is the ideal gas law. So you might have gone through this graph, where Z is your compressibility factor with Z versus P, that is pressure, and these type of graph. I think you might have came across this one. So this particular temperature is we called as a Boyle temperature, right? So if we see, like, from here, your temperature is T3 is greater than T2 is greater than your T1 is like lowest temperature. So this is somewhat related to this. Okay. So next question is, a certain gas has Vc equals to 0.7893 decimeter cube per mole. So the radius of the gas molecule, assuming it to be a spherical is. So here what we are having your
Your question
VC.
is not visible. Now it's visible. Yeah.
Okay, so your VC is with you. Okay, and next is what you have to find, your radius. Okay, uh, just wait for a while, I just come. Okay, sorry for the interruption. Okay, so in this question we have to find the radius of this gas molecule. Okay, so your VC is equals to, let me write it down all this for you, and you have to find the radius. Okay, so you know the formula, this VC is equals to 3B, right? Okay, so that means this value, this VC is equals to 3B is equals to 0.7896. Okay, so next is, now we have to use one formula which includes your volume, so that we could find the radius of your radius of this system, of this gas molecule. So the formula is, so we have to like use a formula related to this B. Okay, so this B is equals to, so here is the volume of your sphere, and this is your Avogadro's number, and this 4 means this is your gas molecule, and it's being interacting with further molecules. Okay, so that means your one molecule is going to interact with 4, so this is that number. Okay, so the volume of sphere is, so can anyone tell me the volume of sphere?
4 by 3 pi r cube.
Yeah, 4 by 3 pi r cube, right, correct. Okay, so let's put this into this equation. Okay, okay, this is your B. So your this volume given was 0.7896. Okay, so now your V is equals to 3B. So now from here you have to find the value of V, so that we can put it here, or vice versa, like V by 3B over here. So let's find out from here. So can anyone calculate this value?
Ma'am, it's 0.2632.
So everyone getting the same? Okay, so let's use this value over here, like put it here. Okay, so from here, okay, so at the end this is what we are going to get, and one factor we missed over here is n naught. So what is your Avogadro's number? So anyone remember?
6.0
Yeah,
6.023 into 10 to the power 23.
yeah, good. So we are going to use that number. Okay, okay, now calculate this one. Okay, calculate this one and let me know the answer, what you are getting in decimeter also. Don't change the unit, I will change it later on.
It's 2.96 into 10 to the power minus 9.
Minus 9, okay. What you told? 2 point?
96
Yeah,
into 10 to the power minus 9.
okay, this is your decimeter, right? Okay, so now get back to your question. So here your values are given in your Armstrong unit, right? So that means you have to convert your decimeter into Armstrong. So let's do it. So for 1 decimeter, how much centimeter we have? 1 decimeter equals to 10 centimeter. Okay, so let's put it over here. Okay, so now you know your 10 to the power minus 8 centimeter is equals to 1 Armstrong. So that means 2.96 Armstrong, right? Any confusion over here? So our answer is this C, 2.96 Armstrong. So others are also getting the same answer. So if everyone is getting the same answer, shall we move to another question?
Man, we can move to next question.
Sorry?
Yes, we can move to
Okay,
next
okay, okay,
question.
fine, okay, fine. Okay. This is your next question. So here your question says, assuming CO2 obeys a van der Waals equation of state, so the pressure in atmosphere, that is ATM, of 10 moles of CO2, that is A is given to you, this A, B is given to you, and occupying a volume of this much, volume of this, and what you have to find? You have to find the pressure. Okay, so everyone knows this equation, your van der Waals character equation. So what is that equation? Right, this is your equation. Okay, you have to find the pressure. Okay, so this is your pressure equation. So now what you're having here, n is equals to 10 moles and your A is equals to 3.59. Your B is 0.0427. Your volume is 50 liter at temperature 300. So you just need to put these values in this equation. Okay, okay. So your R will be 0.872 liter atmosphere per Kelvin per mole. So we have used this R. Now put the temperature 300 Kelvin. Okay, V minus NB, that is V, and your minus NB, that means your 10 minus NB. So your B is what else? Okay, so this is your first equation. So that means you have to subtract the another part, that is n square A upon V square. So your n is 10 square 3.59, that is atmosphere liter square per mole. This is your 50 square. Okay, let's solve this one and let me know your values of this particular part, this like before subtraction, like this particular part and then this particular part.
for A part, it's
Yeah.
okay. I have no, I have not squared. Calculate again.
Okay.
It's 49.62.
Okay, for this above part, right? How much?
49.62.
49.62. Okay. So what is the unit?
It will be atmosphere. It's pressure. No?
Yeah. Okay. So let me know the other part. 10 square, this one.
0.1436.
So everyone getting this?
Yes, ma'am.
Okay. Then subtract this from this equation.
49.48.
Okay. So have you calculated correctly? So we are not getting the same answer here. Please check your calculations again. And you have to use your n equals to 10 moles, A is equals to 3.59, B is equals to 0.0427, and your volume is 50 liter, and your temperature is 300 Kelvin.
Oh. It's 4.962. The first term.
Okay.
49.
Okay. 4.962.
Hmm.
Okay, 4.96. Okay. And your another term, is this correct or this is also wrong?
No, no, that term is correct, ma'am.
Okay.
Ma'am, it's a 50 square, no?
Yeah,
In
it's a volume
calculation.
square. It's a volume square, right? Yeah, this n square A upon V square.
Okay, okay.
V square your volume, yeah.
So the answer is 4.82.
Oh yeah. So yeah. So your answer is 4.82. C. So everyone is getting the same answer now. Anyone facing any problem?
No,
Where
ma'am.
are these questions from?
Uh,
Assignment.
you are getting your you have assignment, right? You are having two
Yes, ma'am.
assignments, I think.
One
So
is
so
the one
one
which
is
will
your
be.
graded one, another
Uh,
one is your non-graded one. So we are doing non-graded one in this
okay.
week. So that I
Before
think you.
we take up the next question, I have a few questions to ask.
Yeah, sure. Oh, okay.
If
Okay,
you,
let me complete this one. What I'm
okay,
saying. I'm saying in this session, like in today's lecture, I'm only covering your non-graded assignment question.
okay.
Okay. So when your deadline will be like over for your assignment, then I will cover your assignment questions too. Okay. So most probably in the next lecture, I will cover up your assignments if the due date is
No,
over.
this
Okay.
lecture it won't be there. It has to be the one after
Sorry.
because the last date is 9th.
9th. Okay, so our
That's
next
2 weeks
on
after.
next date, on what date we are meeting? Okay, that will, okay, then most probably next to next week I will cover those questions then.
Yeah.
Yeah. Yes,
So can
what's
I
your
ask a
question?
question? Yeah. If you see the graded assignment,
Yeah.
go to question number.
You one thing I would like to answer over here, like
Yeah.
I'm not I'm not be able to answer your graded part questions.
No,
I can
no,
help
I am not
you. I
asking
will
you
like
to. I am not asking for
give
the
you the
solution.
hint related to the question.
No, no,
So
no.
in
I am
that
not
way you
asking
can
you.
ask me. Okay.
No, I am not even asking for a hint.
Okay. Okay. Go ahead then.
Can you see question number 7, please?
Uh, wait a second. I have to then look into the question.
Yes, please.
Okay. Can you tell me the question? Like I can check from other
Calculate the
way.
molecular formula of phosphorus.
Phosphorus.
Hmm.
Okay, let me log in then. Wait a second, let me log in, then I
Yeah.
can check. Okay,
Okay. Can you see the question?
yeah, your question number fourth, right?
Please, 7.
Seventh. Okay. Yeah, what's your question here?
See, the question says calculate the molecular formula, right?
Hmm.
So the option should have been P1, P2, P3, P4, something like that. Because you have asked for the molecular formula,
Hmm.
correct? The answer given is molecular weight.
Okay.
So first of all, there's a mismatch in the question.
Okay.
Okay. And
Okay.
number two,
Hmm.
actually, this question is there in Atkins' book.
Which the same question that you are asking?
Same question is there.
Okay.
Okay.
Huh.
But over here, the pressure is 16 kilopascal.
Okay. Okay.
So as a result of which, the answer comes okay.
Okay.
Whatever answer we are looking for,
Huh.
the phosphorus in whatever it forms, it is
Hmm.
there.
Hmm.
The answer you get.
Okay.
But over here, the pressure has changed.
Okay.
Is 1.6 is given instead of 16.
Okay.
So the answer you get, the molecular weight is an absurd number which makes no
Hmm.
sense.
Hmm. Hmm.
So this is something that I want to just
Okay.
to bring this into your notice.
Okay. Okay. So I have not prepared your these assignments. So I
No,
request
that's
you
fine.
to you have forum, right?
Yeah.
So yeah. So you can put this as a discrepancy over there. Okay. So the other TAs who are preparing these like this question list or assignment questions or something like that, they might look into it. Okay.
Okay.
So your observation is obviously good. I think you are working hard for this course, and you come across this discrepancy. That's good, and you're reporting it, and you report it. I think you have to report this discrepancy, and put your question on your forum the way you explained me. Okay. And I don't think they will deduct your marks for this, but this is, if this is so the way you are telling me, then definitely they will look into it. Okay. Any other question? Others are okay, right? Oh, sorry for this interruption. Okay. Sorry for this interruption. So yeah, uh, so my point was clear, or it interrupted in between?
No, no, my thing is,
Yeah.
even if you
Huh?
overlook this pressure factor,
Hmm.
the question itself is not framed correctly.
Yeah, I got your point. That's good that you bring out this discrepancy. It's good. So I'm requesting you to put it on forum. So I think that's the right place to put it on. Cause I am not like the
No,
owner to
normally
check this or
in
some.
other
Hmm.
NPTEL courses that I have done,
Yes.
so normally what we do is we report to this to the TA,
Okay.
and this TA then puts this forward and through their channel, and either they change the question or gives mark to everybody, one of them. It really doesn't matter.
Okay. So if this is so, then let me also put it on forum if this is like, because
Okay.
I am taking this first time.
Yeah, no problem.
So yeah, so might be possible that I am not aware of it. So yeah, definitely I can also put it on forum, and you can also put it on. So definitely I can reply and forward your question there also.
Okay.
Yeah.
Yeah. Yeah.
Okay. Okay. Anyone has any other question, or shall we move to another one?
Ma'am, actually I have one question.
Yes.
It is regarding Andrews curve. Andrews curve we get now regarding liquefaction of gases. We get Andrews curve. There, then we use the van der Waals equation. At that time, we often get a loop type of situation. When loop comes, van der Waals, that Maxwell loop is called. So, some books I saw like Castellan, they are writing that some supersaturated states are being formed. So, what are those kind of states? So, if you can explain those Andrew curve using van der Waals equation, where van der Waals loops comes. Because when we use that van der Waals equation, so it is a cubic equation. So there we get the loop. So that Atkins has written that it is Maxwellian loop. So how that loops comes and what are the significance of that loop? So if you can explain that.
Okay. For this, it will be better if you will put me a mail. Okay, in next session I will take forward your query so that I will also read this part. Okay, and then I will be like able to explain you better. You put this question to me on my mail. Okay, then I will take forward your question in next week, if this will be fine for you.
Okay, ma'am. Please give your email ID, ma'am. That will be better.
Yeah, sure. So I can write it down, you can mail me. Okay, this is my mail ID. So you put your query over here. So I will take those queries and will try to solve and will try to explain your queries in next upcoming week, like in interactive session that we will be having. Okay,
Okay, ma'am.
so any other person who has this type of queries, and they are also free to ask me and mail me so that I could take your queries in my next session. Okay, okay. So this is your fourth question. So question says the critical temperature and the pressure for nitrogen are, so your TC and PC, right? So your TC is 125.97 Kelvin and your PC is 33.49 atmosphere. Okay, this is for your nitrogen. Other one, and those for the hydrogen, your TC is 33.2 and your PC is 12.8 atmosphere. And what you have to find, the ratio of diameters of nitrogen and H2 molecule, the hydrogen molecule. Okay, diameter means your double of your radius, right? Okay, so let's try to find out the relation between this PC and TC, and then we can see how we can move forward to get the diameter ratios. Okay, so we know this term. Right, so I'm not putting C like critical conditions over here, so let me explain this part. Okay, so this NR is your constant, right? So we can compare your PV upon T with your nitrogen part and your hydrogen part, that is your PC I think, let me write it on next slide. So can we write in this way? Okay. So now what you have to find your.
Ma'am, I have one question. Here, we are assuming that these nitrogen and hydrogen are ideal gases because we are using that P1 V1 by T1 equal to P2 V2 by T2. So, if we are assuming it like an ideal gas, then ideal gas is not having any size because ideal gas are not having any diameter. Those are only point masses. So, how we can use those ideal gas equation for finding the diameter?
I'm not saying we are using an ideal gas, but I'm saying your this particular term PV upon T, this term is constant for, like, this term is constant, right? So we can use it to define, find out the VC for the VC ratios. If you're when you're finding your ratios, your A and B, these are also constant, right? And when you're finding your ratios, like here what I'm trying to do, I will try to, like, do it like this. Okay, so what I am doing, I'm trying to find out the ratio. Ultimately we are finding the ratio of this diameter, right? This diameter, right? So to reach here, so I'm using this volume, okay, so that we could reach till the diameter. So I'm only using the ratio part because we are only having information of this pressure and temperature.
Uh, it is true, ma'am, but whether it will not affect that because these are not ideal gases, na?
Yeah, I agree. Yeah, so you are saying me to use this equation, right?
Yes, because their A values will be different. A values that attraction parameter A value will be
But
different.
I don't have a value. The question is saying you, giving you only pressure and temperature. So on that basis, how you will find it?
Yes, ma'am.
Your A and B are not given. So here your A and B is, like, there is written, this is your van der Waals equation, right? So that's why we have used this equation. I agree to your point, but how we
Okay,
can
ma'am.
include A and B over here?
Okay, ma'am. We cannot calculate. So, it is
So
okay.
I think the till the time we are talking about the ratios, or we are moving with the ratios ahead, so that's why maybe like this solution is this way. Or you can try it by your own. If you find it, then let me know in next session.
Ma'am,
Okay.
is it possible that we should take V minus B ratio, V minus B? That because V minus term is often coming in van der Waals equation. So V minus B term is there because pressure, if you are assuming that pressure is, if we are neglecting that both A part are constant,
Hmm.
so same,
Yeah.
then V minus B term, whether we can take ratio because B will be there, na? B of nitrogen will be there and B of CO2 will be there.
Okay. So ultimately, what I am using here is this one, this B. Okay. So I'm introducing the B from here. I'm
Okay,
only
ma'am.
taking out the ratio of your volumes so that I can put it into this B.
Okay, ma'am.
And these equations are derived from your after your, like, van der Waals correction, right?
Yes, van der Waals equation.
Yeah, right. This is A upon 27B square, 8A upon 27BR, and 3B. So this A and B terms are van der Waals corrected terms. So by using this one, we are only getting the ratios. Ratios means this volume of your nitrogen upon your volume of your hydrogen, the ratio part. Okay, and ultimately we are putting into your this van der Waals corrected equation. That is VC equals to 3B, right? Still doubt?
Yes, ma'am.
Still doubt?
No, okay, ma'am. Okay, ma'am.
Yeah. Okay. Okay. Let's put this in this equation. How much is PCH2?
Ma'am, it's 12.8
Okay,
PCH.
12.8. Okay. And temperature of nitrogen?
125.97.
Okay. And for pressure of nitrogen?
33.49.
Okay. And temperature of your H2?
33.2.
33.2. Okay. Okay. And let me know this answer. Know the answer.
1.45.
1.45. Okay. So others are also getting the same. So this is the equation that we have used in our earlier question also, right? Okay. So when we are doing the ratio, so this this three part will go away, right? So this VC nitrogen upon hydrogen upon this is for nitrogen, and this will be for your H2. Then your 3 part will be over, right? So that means your B. So this B is equals to 4V into N naught, right? Okay.
Hello?
Yeah.
I think there might be a better way, another way to solve this.
Okay.
But, can you just go back to that slide where you wrote the formula for PC and TC at the
Uh,
beginning?
at the beginning. Okay. Yeah.
Okay. Now PC and TC are given for both, right?
PC and TC, yes.
If you take the ratios,
Hmm.
only one B term will survive
Okay.
because AA will get cancelled.
Hmm.
B term will get, you will get B. From there you can get VC, and from there you can get the volume and you can get the diameter.
Okay. That's also nice. Yeah. I think both way will work, right? This will also work, yes. Okay. Let's move ahead. Okay. So this is your system. So this is your radius. Now I want to make it a diameter. Okay. So I will take out few terms inside it. Okay. Is this okay? I am having 4 into 4, right? So my radius, this is my radius. Now I have to make it a diameter, right? So I want 3 2 to get inside this cube. Okay. So now this is my diameter. Okay. So now what I am doing, you're using this equation, and by putting this one, that is 2r. Okay. So I'm donating your 2r by d. Okay. So So these all these parts 2 by 3, so let me divide it. N naught by, this is your D cube for your nitrogen, and D for hydrogen. Okay, and your value was, this is your V C 1.45, right? Okay, now see, your these parts are cancelling out. Okay, let's move ahead. Okay, so let me know the answer for this.
1.132.
Okay, 1.132. Okay, so this is close, right? 1.133, right?
No, ma'am, C1. No?
Oh, sorry, yeah, C, sorry. Okay, correct. Your C. Okay, 1.13. So everyone getting the same answer? So can we move to next question?
Yes, ma'am.
Okay. So your next question is, a sample of hydrogen gas was found to have a pressure of 250 kilopascal when the temperature was 23 degrees Celsius. What can its pressure be expected to be when the temperature is 11 degrees Celsius? Okay. Your pressure is given. This is your P1, this is your P2. P2 you have to find, right? And your temperature T1 is given 23 degrees Celsius, and your temperature T2 is given 11 degrees Celsius. Okay. Now here, which equation you will put it in to find this pressure? Which equation you will use?
Ideal gas.
Ideal gas. How? Okay. Okay, for Sandeep is saying we can use P2 upon P1 is equals to T2 upon T1.
Yes.
Okay, so everyone is agree to this equation? How they have derived this equation? From your idle gas, right? Okay, so now here your pressure is directly proportional to your temperature. So from here we can use it in this way, like P2 upon P1 equals to T2 upon T1. So now put this into the equation and try to find out this P2 term.
Ma'am, 239 kilopascal.
Two.
239.86 kilopascal.
Okay, how much you told?
239.86
Okay, kilopascal. Okay, so everyone getting the same? Okay, so that means we can round it off to 240, right?
Yes,
So,
ma'am.
so yeah, so your answer is C, 240 kilopascal. Okay. So okay, I'm giving you these three equations. PC equals to A upon 27 B square, and this TC equals to 8A upon 27 BR, and BC equals to 3B. So I want the value of ZC. So can you put into the equation and use this all values? No, I know the answer 3 by 8, but I want you to solve it by putting this into the equation. And I want the answers from others also. Okay, so everyone know get how to get the value of this ZC. So everyone knows how to calculate the ZC. Okay. Okay. Yeah. Sandeep is correct. We have to put these values PC, TC and VC into the equation where ZC equals to PC into this. What's the equation that he has written? PC into VC upon RTC, right? So by
Yes, ma'am.
yeah, so by putting all this term into the equation, you will get this answer. Okay. So in this session, I have only included your 5 questions other than your non-grade, other than your graded one. Okay. So we have finished this question. So let me know any issues or any problem or any question where you are struggling. And we have another half an hour, I think. Do you want to discuss something? Do you have something to discuss? Or should we take one more example? I think we can solve 1 or 2 examples. Okay. Let me take other examples. Okay. Okay. So your question is, okay, there is a gas following your van der Waal equation state, and where your TC is 304.2 Kelvin and your PC is 72.8 atmosphere, and your constants are A and B, right? And you have to find these two constants. So will you try this question? So I will write the equation over here for TC is equals to 8A 27BR, and your PC is A 27B square. Use this term to find out the A and B. Okay, I'm dividing your TC and PC. Okay, so from here we are cancelling 27, 1B, right, and your A part. What we are getting, eight R B, right?
Yes, ma'am.
Okay, from here I can take out B, TC upon PC into R upon 8. Can we write in this way?
Yes, ma'am.
Yes? Okay. So what is the TC? 304.2. So what will be the value of R?
0.082
Okay, and your unit will be liter
atmosphere per Kelvin.
per Kelvin and per mole, right? This is your R. Your PC will be, what's your PC? Into 8, right? So from here your atmosphere cancel out, your Kelvin and Kelvin, and you left with liter per mole, right? Okay, let me know the answer. What will be the answer after solving this?
Ma'am, 0.0428
Okay, and your unit will be
liter per mole.
liter per mole. Yes, right? Now you have to find out your A. You can put it in any equation, right? Yes, either you can put it in your TC or in your PC, right? So I am considering your TC near A will be What is your B? This is your B, right?
Yes, ma'am.
Okay. And your R will be 0.082 atmosphere liter square per Kelvin per mole, right? Upon it. And now your per mole will cancel. 1 liter with this, right? So what will be the answer?
3.60.
Yeah. Okay. So everyone getting the same answer? So everyone getting the same answer, right? Done?
Yes, ma'am.
Yes? Okay. So any doubt in these questions that we have solved today? So everyone is clear with everything? Okay. Yeah, Sandeep, you were having one question, right? So please do mail me. Okay. So I will get back to your query again.
Okay, ma'am.
Yeah. Okay.
Okay.
I will try, and do send me the link that you are following. Okay, the book that you are discussing.
Okay, ma'am. Okay.
Yeah. Okay.
Okay.
So tell me one thing. So you have studied this part in your the question that you are asking. That part is in your syllabus. Like it has been covered in your videos or something. It's other than that.
Uh, yes, liquefaction of gases has been covered.
Sorry.
That liquefaction of gases, that Andrew
Uh-huh.
curve, that part has
Okay.
been covered also.
Okay.
But
Huh.
he has not explained that Maxwellian loop. That loop comes when we use to explain the van der Waals equation, because van der Waals equation is a cubic equation. It
Van der Waals equation
is a cubic equation. Cubic.
cubic.
Here
Yes.
the
Yes. Huh.
yes here the power of the volume is 3.
Yes.
So it is a cubic equation.
Hmm.
So actually there are 3 roots. So
Hmm.
when we apply this van der Waals equation at the critical point,
Hmm.
then we get only one solution. That PC, VC, and PC comes when we equate that V minus BC V minus BC whole Q equal to 0. Then from there we get that after equating we get the value of PC, BC and PC.
Okay.
But when we are below that critical temperature, then actually we get actually three roots.
Yes.
Three roots. So they are the roots value. So but those equations are having some loop kind of shape. It is a loop kind of shape. So that thing in Castellan when I was reading, then they have mentioned that actually some supersaturated state is there. So although we are increasing the pressure, then volume also increases. So those kind of a state, because in general when we increase pressure, then the volume decreases. But in those kind of loop situation, we often get increase in volume with increase in pressure. So that is totally unrealistic. Na? So there I was finding it difficult to understand.
Okay. And please do send me that link, the book that you are following, okay, with the page number and all, so that I will look into that part. What is the special case that we are talking about? Okay. So I think you are talking about this equation, right? V minus this Vc upon this cubic, right? And we open up this equation and we get the three roots of this, right?
Yes, ma'am. Yes.
Okay. So you are confused with your pressure and your volume,
Yes, ma'am.
This behavior, right? The irregular behavior of this.
Yes, ma'am.
Okay. So have you read about any example over there? Like, is there anything that they have mentioned this is your exceptional case?
No, because experimental graph is there. In the experimental graph, when we start increasing pressure, then below the critical temperature, we find a situation where the when it is inside that liquid loop,
yes.
Liquid, when it is inside that liquidous portion, then we get on increasing a small amount of pressure, we find a large decrease in volume. There, the liquefaction of gases starts. But this is actually experimental graph. When we try to analyze this problem with the help of Van der Waals equation, because Van der Waals equation is a theoretical equation, it is not an experimental equation. So when we try to fit that equation, then where we start getting loop kind of situation. Van der Waals loops, because only at critical point we are writing V minus BC whole Q equal to 0. It has only one loop, but below that point actually three roots are available, because this is a cubic equation, so we are getting three roots. So at 3 point it is cutting the liquid portion, time. So there.
So you are talking about this particular graph, right? So
yes,
this graph, like here, this is your pressure, and
yes,
the like. From here you are getting your this one volume, another volume.
Yes,
that means you are at one pressure you will be having three volumes, right?
Yes, yes.
By solving this equation.
Yes, ma'am. But it is 0 at 3 values of volume. Yes, ma'am. Yes, ma'am. Okay, ma'am.
Yeah.
Yes, ma'am. It is also there in Atkins, ma'am. Atkins it is written, and they have written is that Maxwellian loop.
Okay.
So in Atkins also it is there, but they also have not explained it in a detailed way.
Okay.
And in Castellan, in Gilbert Castellan book, they have mentioned that some supersaturated state comes, where although we are increasing the pressure, like we can see in the graph which we have made now, there it is loop kind of scenario. So we are increasing the pressure and the volume also increasing. In the second portion of graph, the midway, just before the midway point and just after the midway point, just one. Before it and after this.
Like so from here to here, right?
Yes. So when we are increasing the pressure, then volume is also increasing. So that kind of situation, some supersaturated state, something like that they have mentioned, which I do not understand.
Okay, some type of super cooled liquid and.
Yes, ma'am.
Okay. I will look into it, and we'll try to explain this graph again. Okay.
Okay, ma'am. Thanks.
And please do mention your page number and your books. If possible, attach your screenshots, like your book,
Yes, ma'am.
your paragraph that you are
Yes,
reading. Okay, so that
Yes,
will be
ma'am.
much more pinpointed, that I will cover up your topic. Okay,
Okay,
more
ma'am.
clearly. Anyone else who is facing any problem in any of the topic? Okay, if you even find out later on also, one thing you can do, like we are having a class on Friday, so till Wednesday or till Thursday you can mail me regarding your topics, that is not the topics that you are not able to understand. Okay, so I will try to take your topics in the upcoming interactive session. This will be fine, right?
Yes, ma'am.
Yes. Okay. Yeah, so at least one day before you can let me know your topics, where you are confusing. Okay, and I will try to cover up. Okay. Okay, any doubts now? Any other questions, any other doubts? Okay, shall we wind up this class then, if there is no other question? Okay. Okay,
Yes.
thank you all for joining, and we will meet you another next Friday at the same timings from 6 p.m. to 8 p.m. Okay. Okay, thank you everyone. Thank you.
Thank you, ma'am.
Okay, ma'am. Thanks.
Okay.